Hi everyone, welcome back. Grade 12 learners. We are going to continue with your questions and answers day 11. Today's topic is projectile motion. As you know, we have one multiple choice question and then one long question. Let's see our multiple choice question first. All right, please try first and then you can check correct answer. Okay, this is our question. A ball is dropped from a small height. So you please read question and try. And then we can carry on, we can answer with you. The following pairs show physical quantities, okay. One of these pairs will both quantities change while ball is falling. Okay, so for free fall, which one of these same? For free fall. So we are going to work with formula for each, and then we can get our answer. Let's draw our diagram first. What we have, a ball is dropped from a small height. Okay, we have one object and drop from small, just from high. Okay, so we have H here. They said dropped from. Dropped, it means V initial or V0. You can say 0. Initial velocity is equal to 0 meters per second. So, and then mechanical energy. Mechanical energy is constant or not for this motion. So what was the mechanical energy? Mechanical energy is equal to kinetic plus potential energy. Kinetic plus potential energy. So for this position, we have potential energy. When object is going down, change to kinetic energy, but mechanical energy is constant. So mechanical energy is same, number one. And then weight. Weight equals m times g, mass times gravity. Gravitational acceleration is constant on top, or it's coming from the same mass. Still, we are using same object. So mechanical energy and weight will be same, because we are looking for both quantities change. So both of them same, so they don't change, they are not changing. So we can carry on with option B, kinetic energy and momentum. Kinetic energy is changing because initial velocity equals 0 on initial, and velocity increasing. Kinetic energy increasing. And what about momentum? Also increasing, because momentum, kinetic energy formula, that's right. Kinetic energy is equal to 1 over 2 times m times v squared, and the momentum equals mv. So velocity change, momentum, and kinetic energy both change. The answer is B, but let's check other options. Gravitational acceleration will not change, just g is equal to 9.8 meter per second square. So we have constant acceleration, kinetic energy change, but they said both change. So option C is gone. And then option D, potential energy, gravitational potential energy decreasing, because on height, highest potential energy change to kinetic energy, changing, decreasing, but gravitational force and weight, same thing, still constant. Weight or gravitational force, same stuff, you know, m times g, they don't change. Gravitational force, it doesn't change. So potential energy changing, but they're asking you both change. Answer is B. All right, we have done our question 1. Let's continue with next question. Question 2 is coming, long question is coming. Answer is B, yes, and then let's continue. Okay, let's see what they ask now. A small disk, C is okay, it's going up, all right, with 15 meters per second. So initial velocity is 15, it's going up, all right, from this corner, all right. Initial height is 30 meters. And after 0.5 seconds, okay, just C is going up. After 0.5 seconds, B starts going up, vertically up with 40 meters per second. Okay, this is our motion. And then they said ignore the effects of air resistance. All right, this is our question. Let's see. Explain the term projectile. As you know, most of questions coming with definition. Each definition 2 marks. So please try this one. Projectile motion definition is here. You can just write. We should memorize them. Nothing to do. Let's see marking guidance here. If something is missing, unfortunately, you are losing your mark. An object which has been given an initial velocity, and then it moves under influence of gravitational force only. An object which has been given initial velocity, and then it moves under the influence of gravitational force only is in free fall. All right, so please try to memorize this definition. This is definition for projectile motion. An object which has been given an initial velocity and then it moves under the influence of gravitational force only is in free fall. All right, let's continue with next one. Let's see what they ask. 2.2.1. Time taken by disk C to reach its maximum height. Okay, we know initial velocity. And then for B, just for this kind of questions, please separate objects. Just don't calculate same time. Just think with one object to make it easy for you. Question 2 to 1, we are busy with object C. For object C, what's our initial velocity? Because we are using our equations for motion, equation of motion we are using. For C, our initial is, okay, let's draw it here. For object C, object E. C, initial is 15. V initial is equal to 15 meters per second, okay? And then when it's going to highest point, we should just remember at highest point, your V final equals 0. If you know that, if it is 0, from now it is easy, right? Just use up is positive or down is positive. Let's see our options for solutions. First of all, you can just redraw diagram with V initial, V final, and whatever else we know, gravitational, everything, all details you can write with another diagram, and then it's going to be very easy for you. Let's see our solution now. Option 1, up is positive. If up is positive, let's draw here for this one. V initial equals, okay, let's draw this side just like the other one. So V initial equals 15 meter per second. We said up is positive, so 15 is positive we are going to use. And then it's going up. V final is equal to 0. They didn't tell us it is 0, but they said maximum height. Maximum height means at that point you have 0 velocity. And then what about your gravitational acceleration? Gravitational acceleration you are going to use negative 9.8. G equals minus 9.8 or minus G, you can say. We are using for acceleration minus G minus 9.8. Why? Because gravitational acceleration is going down. And you said up is positive. Because of that, V initial is 15. This is our formula. From formula box, you are getting it. And then just put all given, substitute, and then you can calculate. V initial is 15, acceleration is minus, and then getting time. Done. Okay, so this object C is going up at highest point, going to highest point in 1.53 seconds. All right, so we have done without wasting time. Let's continue. Next one, another option we have. Now, up is positive option 2 for maximum point time taken. Now, for this option, they said, or if object is going up to highest point, and from highest point, object will come to initial position. Now you are saying initial is equal to 15 meter per second square is coming down, and then it is coming down option 2. Okay, let me just double check. Why is it negative? 1 minute. All right, for this kind of motion, this is your V initial equals 0, sorry, below 15. Final is minus 15 meter per second. Because we know when object is going up, it's going to highest point, and from highest point, it's coming back. So you can use this motion when it's coming to same level, same position. V final is minus 15, and the V initial equals 0. Acceleration still negative because you said up is positive. And then V final is negative because it's coming down now. You are just using second motion. When it's going up, we did use in option 1, that one. Now option 2. You can use any of this, but remember acceleration is negative. We are choosing up, positive. All right, so we have done this question. Let's continue. Do you have another option? If we have, we can just explain. Now, another option we have. For this option, this is our V initial. This is our V initial position. V initial is equal to 15 meters per second. And then object is going up and coming to same position. So this is your V final is equal to minus 15 meters per second. But please remember, now we are calculating object is going up and coming back, total. So when you calculate with this formula, negative 15 and 15, you're getting 3,06. So this is not your final answer because we are looking for only how long it's taking to go up. So divide by 2. All right, just you are calculating, divide by 2, and then you can get your answer 1.53. Okay, well, this is our answer for this question. I think enough options. You have different options you can use. In memorandum, you have different options using another formula is here. As you see, delta y formula. If you are using delta y, V initial is equal to delta y is equal to 0y because we are using this motion. Object is going up and coming back to same position. If they are coming to same position, delta y equals 0. V initial is 15 because it's going up. You said up is positive. You are just accepting that. And then acceleration is minus 9.8. You are calculating that, but still same process, divide by 2 because you are calculating total time for this option. All right, let's continue. You have different options. Which one is easy for you? You can use that. I think that's enough. Now let's continue with next question. Maximum height for C. Okay, now we know time. How long is taking going up? We know the initial. So if you know this all, easy to calculate your maximum height. So let's write it down. First of all, please remember you should choose which side is positive. Now we said up is positive, and then object is going up and then coming back. So let's use different options, same process. Firstly, let's use from this position, from initial position, just going up here. So V initial equals 15, positive 15 meters per second. Time, you know, you calculate in other question, 1.53 seconds. V final is equal to 0. If you need, you can use it. And we are looking for an acceleration is equal to 9.8 meters per second. Let's say A equals 9.8 meters per second square. So you know everything. So now you can use this formula or another formula you can use, guys. So delta y is equal to V initial times delta t, and half acceleration should just substitute this formula, and then you are getting 11.48. But we must add 30 meters because they said maximum height from ground. So when you calculate this, you are getting 11.48 meters from initial position, but from ground we have extra 30 meters. You're just adding 30 meters and done. All right, let's continue with next question. Oh, sorry, next option. We have just using other formula. All right, so using other formula for option 2. Option 3, option 4, we have different options, but same process, just using different options, different formula. If you just choose which one is the initial, which one is the final, if you know them, it is easy for you. Even downward positive you can choose. If you are choosing downward positive, just remember, initial positive. Yeah, we have different options. Just leave it, you can carry on, you can check the other options. Okay, next question now. Calculate the time from moment that disk C was upwards until the time ball B hits the disk. Okay. Calculate the time from moment that disk was upward. Okay. So we are calculating time when they come together, when they touch each other. So what we are going to calculate now? Formula substitute. So we are drawing. Okay, we are going to draw graph, but before that, we must calculate time. How we are going to calculate this one? First of all, delta yc minus 30. They said because there, this is your delta yc. You are just calculating highest point. This one is showing you highest point from this position here. So delta minus c is giving you position of c. And then the initial 15 times delta t, and which one we said upward is positive, all right. And we are calculating, so this question, we are calculating for C and for B. After that, you can just combine these two equations, and then you can calculate, first of all, for C, what we know, delta y, the yc minus 30 is giving you position for C when they meet each other, not just highest point, we just said. So not just highest point, just position for delta t. We don't know how many seconds, we are looking for that. Calculate the time when they come together, when they touch each other. So for this delta yc minus 30 is giving position, maybe here, but you can get negative, it's fine. But yc minus 30 is equal to 15 times delta t, because v initial is equal to, v initial equals 15 meters per second. Acceleration is negative because you said up is positive, acceleration is going down, so acceleration is minus 9.8. So if you write this equation, you are getting first one here, you have two unknown, position for C, and then delta t. And second one, now you are busy with B minus 0, we said, because start from initial, yb minus 0, and the v initial is equal to 40, positive 40, because it's going up, as you see. And then time is delta t minus 0.5. Why we are doing that? Because they said B start moving after 0.5 seconds. All right, after 0.5 seconds, delta t minus 0.5 we are using. So just carry on, 1/2 minus 9.8, delta t minus 0.5 square, and then you are getting yb, another equation. So this you have another equation. So what we know, yc equals yb, because they said when they meet together, when they touch each other. So it means positions coming, say maybe C is going up and coming to this position, and B is coming up this position. Maybe they meet here, we don't know, but we know this position, they have same position. So you are gonna just write this first equation and second one, they are equal. So you are getting time, if you use that, 1.71 seconds. I hope it is clear. This one hardest one, highest level, but we are using, as you see, we are not separating first. Firstly, you are writing for C, our equation. Just remember, you are using delta t, but next one, delta t minus 0.5, because start moving after 0.5 seconds. This is our answer for 2.3, done. Let's continue with next one. So this one was that one. And then other options you can check, plus minus, same thing. You are making two equations with different formula, and then you can calculate. Now they're asking you draw a graph. So which graph we are gonna draw on the same set? Okay, for B and C, we are gonna draw a graph. So what we need, initial velocity for B and C, we know already, C 15 meters per second and B 40 meters per second. Time which pole B was shoot upward, okay. Time at which pole B was shoot upward, okay. And then time at which this reached maximum height, we calculate already. And then time to which pole hits disk C. That time we calculate, to remember, 1.71, right? It was 1.71. We're gonna show that time also. Okay, so now let's see, in this graph, we should show everything, all details. Initial for C, 15, and then C is coming to highest point. When it is coming to highest point, what we know, velocity equals 0. As you see, for 1.53 times velocity equals 0. and then it's coming to here 171. Why? Because they are coming to same height. So as you see, just coming once this time, you just show together. And then initial for B 40, but start from 0.5. All right, this point is important for this question. Most of questions just start from there, but now start from 0.5 seconds, because till 0.5 seconds, B is not moving. And just that point, start 40 and then slowing down. As you see, we are just going down. And please remember, they should be parallel to each other. If they are not parallel to each other, unfortunately, you are losing your mark. Please remember that. And then showing for velocity meter per second, time second, for C, B, whatever they ask, we did show. So initial velocity for B and C, yes, here and here. And then time which pole B shoot up, so it is 0.5 is here. And then time discrete maximum height, 1.53. And then when they touch each other, so when they come to same position, 171. Whatever they ask in the question, we should show. All right, we have done for today. I think we have done, just double check. Okay, yeah, another option we have for if you say downward negative, downward positive, so add all velocities will be negative, so other options. Thank you very much. See you next lesson. Please remember, for our videos, please try first and then check answer. All right, please try first and then you can check answer. See you next lesson with lesson 12. Another lesson is coming. See you next lesson, everyone.